Hey guys, welcome back to my video. So today, we're going to prove that this identity is true for the sign of pi over 2 plus I natural log of k plus or minus square root of k squared minus 1 will be equals to k. So, let's get started. Okay, we can see that here is pi over 2 plus something, and therefore should we use this trickle property that sine pi over 2 plus something equals to negative cosine of something? So you may think of it. However, this is not true when x is equals to a complex number. So this situation, this property should be only used when x is in a real number situation. Okay, so how do we do that? I think the first thing we should do is using the double angle formula to evaluate the sine of pi over 2 plus I natural log of k plus or minus square root of k squared minus 1. So let's get started and let's see. The first one will be sine of pi over 2 times the cosine of I natural log of k plus or minus square root of k squared minus 1, and then plus the second one, sine of I natural log of k plus or minus k squared minus 1, and then times cosine of pi over 2. Yes, and we'll expand in this form, and now we see here's the cosine pi over 2, and what is this? This is equals to 0. Cosine of pi over 2 equals 0, and so the whole multiplication will be equals to be 0. And so we left this term here, and sine pi over 2. What is sine pi over 2? This is equals to 1. That means we are now left cosine of I natural log of k plus or minus k squared minus 1 in close bracket. Okay, so we change to this form. This is not the negative. This is not the negative one, so be careful. And then how to evaluate this cosine of something in a complex world? Okay, we know that e to the I theta equals to cosine theta plus I sine theta, and e to the negative I theta equals to cosine theta minus I sine theta. And so, how to find cosine in this situation? We should get cosine equals to e to the I theta plus e to the negative I theta over 2, and that is cosine theta. And when we plug this thing into theta, we will get e to the I times I natural log k plus or minus k squared minus 1, and the second one, e to the negative I times I natural log k plus or minus square root of k squared minus 1 and over 2. All the things over 2. Okay, and then I times I is negative 1. This is negative 1, and we can move the negative 1 to the to the back of the natural, to the back of it. So this thing will be moved to here, and then I times I still equals to -1, but here's the negative sign. Negative times negative will be positive, so it will be +1. +1, so that we can ignore this thing. Okay, and natural law can cancel out with e, so we can cancel out it, and this one also. And so we can move to the next step, that is the k plus or minus k squared minus 1, -1 plus k plus or minus k squared minus 1, no -1 here, and then over 2. You'll see no e, no natural log, no I here anymore. So we can keep doing this by multiplying up and down by k plus or minus square root of k squared minus 1. And so it will becomes plus, this one will be equals to 1 in the next step, and this will be squared, and this will be here. So here will be the first oh, it's okay. Let's look at it first. Equals to a squared plus 2ab plus b squared. And then if we take it here, and a will be k squared here, and 2ab plus or minus 2ab, so that here will be plus or minus 2k times square root of k squared minus 1, and then plus 1. Okay, sorry, it's k minus 1, and over 2 in the bracket k plus or minus k squared minus 1. Okay, so here's the -1 and the +1, we can cancel them out, and then this is k squared, and the k squared can move to the front and becomes 2k squared. This one cancel out, and here we will see here's a 2, here's a 2, and here's a 2, so the 2's can be cancelled out, and we can also factor out the k, so that it will be k times k plus or minus k squared minus 1 over k plus or minus k squared minus 1. And here's the deal, you can see the same thing here, they are the same, k plus or minus square root of k squared minus 1, and then we can cancel them out, yes, and finally we'll get k, so that this one is verified, sine of pi over 2 plus i's natural log of k plus or minus square root of k squared minus 1 will be equals to k. Okay, we have verified it. Yeah, very good. Yay! And so this is the end of this video. Please share and like and subscribe my channel and video, and thanks for watching.